1970s, our understanding of what's necessary for life itself was turned on its head with the discovery of hydrothermal vents. Deep on the seafloor, among huge pillars spilling superheated, chemical-rich fluid, scientists found life forms that don't require sunlight to exist, something previously thought to be impossible. Instead of sunlight and photosynthesis, the base of the food chain at these vent ecosystems was chemosynthesis, or the production of food using energy released by inorganic chemical reactions. But vents aren't the only ecosystems that can support chemosynthetic communities. Once scientists knew what to look for, they found them in hot springs on land, on the seafloor around whale carcasses and sunken ships, and in association with cold seeps around the world. Cold seeps are places where chemical-rich fluids and gases escape from fissures in the ocean floor. Unlike hydrothermal vents, which are fueled by geothermal activity, the seepage at these sites is fueled by immense pressure. Also, in contrast to vents, there isn't a strong increase in temperature relative to the surrounding waters. The chemicals that emerge from seeps are toxic to most forms of life. However, these chemicals, most importantly hydrogen sulfide, methane, and other hydrocarbons, actually provide the building blocks for entire chemosynthetic ecosystems. At the base of the food web are chemosynthetic microbes, some that live freely, and some of which live symbiotically within other organisms. Longer lasting and more stable than their vent counterparts, seeps can persist for decades, centuries, and likely even millennia before subsiding. But they don't last forever. Over time, the toxic flow lessens and stops entirely, and the ecosystem is settled by new species. From both a geological and ecological perspective, cold seeps are prime sites for new questions and answers, and then often more questions.
Hi, everyone. Welcome to tonight's Expert Deep Dive event offered through NOAA Ocean Exploration and the Ocean Exploration Cooperative Institute and supported by the National Marine Sanctuary Foundation. For today's program, I know we have registrants, from far and wide. So we'd like to ask you all to please say hello in the chat box and let us know where you're joining us from. And that's where you can drop your questions throughout our evening. As you know, today our focus is the rather mysterious and fascinating world of deep ocean cold seeps. Again, these are places throughout the global ocean where chemicals like hydrogen sulfide, methane, and other hydrogen-rich fluids and gases escape from fissures in the ocean floor and also support chemosynthetic communities. What you just saw was a short clip from our recently produced Deep Sea Dialogues video, which is a 10-minute piece that's available on our website and beautifully shares the basics of cold seeps through a dialogue with a cold seep expert. We hope you'll explore this a bit more on your own and perhaps use it in your classroom. I'm Susan Haynes, and I'm joined tonight by my colleague Liz Holdley. Liz, would you like to say hi?
Hi, everyone. Excited to have you joining us tonight. Can't wait to share some cold seep resources with you later.
Terrific. Liz and I are thrilled to be here with you all, and our plan for this evening is to spend about 45 or 50 minutes directly with our visiting cold seep expert, providing you with some time to dig into the topic and ask some great questions. And then we'll briefly share a few of the fantastic cold seep education resources we have available to bring this topic alive in your classroom, as well as information about some of our upcoming educator professional development opportunities, during which you can go into a bit more depth in some of our recently developed lessons, our fact sheets, our videos, and much more. And as Liz said, she'll tell you a bit about all of those things in about an hour or so. We are incredibly grateful for all of the support we received from our NOAA Ocean Exploration Education Alliance partners across the country in sharing this particular opportunity, and we're looking forward to our upcoming educator professional development workshops on this topic with them. And just a note that those will be offered both online and in person in the coming weeks. So thanks for saying hello in the chat box, in the comments, and it looks like we've got folks from Mexico City and Texas and Minnesota, and Dauphin Island, Alabama, and San Pedro, California, New Orleans. And I know we've got some registrants from across the entire US, including Alaska. And we have folks from Puerto Rico and from Canada, and even someone registered from Portugal. So we're excited to have you all here this evening and look forward to a great program. And to get us started, we'd like to ask you to take part in a quick poll question. And you can see that popping up on the screen here. To provide your answer, you can scan the QR code into your phone, or you can use the menti.com input and voting code that you see there at the bottom. And you could also use the direct link in the YouTube description if you are using YouTube. So the question is, relatively recently, cold seeps have been found to be much more common and prevalent than we knew in the early 2000s. Cold seeps are now known to exist, A, in every ocean basin, B, along the continental margins of every continent on the planet, C, at active passive margins, or D, all of the above. So take a moment to answer the question, and we'll come back to our poll in just a couple of minutes. And before we do that, and before we meet our expert, just a few words about current ocean exploration. NOAA Ocean Exploration, our office, was established in 2001 with a mission to explore the ocean for national and also for international benefit, focusing on the fact that our global future depends on our understanding of the ocean. And along with federally funded opportunities on a number of different NOAA vessels, NOAA Ocean Exploration operates the NOAA ship energy.Explore. And we at NOAA Ocean Exploration, along with many of our partners, like Ocean Exploration Trust, who operates the exploration vessel Nautilus, and Schmidt Ocean Institute, who operates the research vessel Falkor 2, we all target areas that no one has ever been to before. And in many respects, we really have no idea what it is that we might find there. And over the past several years, through seafloor mapping and water chemistry studying, and expeditions with remotely operated vehicles, we've all been exploring the unique cold seep ecosystems and the communities that they call home. For example, this really diverse community was found in 2020, and this was found by Ocean Exploration Trust aboard the Nautilus. And if you take a close look at this, you'll see this image is being a seep off of the US West Coast. It shows a large group of snails, and it also shows their egg masses, which are the tall yellow towers that you see there. And if you look really closely, you can see that the towers, the snails that built the towers, were using the clumps of tube worms that are there as a place to anchor the egg masses in what would otherwise be super soft sediment. So if you've watched any of our live feeds or videos from our ROV dives from any of our organizations, you know there is always something new to learn when we're exploring the deep sea. So let's take a look at the answers to our poll question and see how folks did. Looks like folks did really well. That's exactly right. The correct answer is all of the above. Seeps are found in every ocean basin, along continental margins off every continent of the planet, and at active and passive margins. So we're going to learn a whole lot more about them tonight. And without further ado, I hope you came with some super questions for our expert. And I am super excited to introduce Dr. Adam Skarke. Hi, Adam.
Hi, good to see you, Susan.
Good to see you. Adam is an associate professor of geology, and he comes to us with a BA in geology from Colgate University and a master's and PhD in geology from the University of Delaware. So you won't be surprised to learn that his research interests are in marine geology and geophysics. His particular focus is on mapping and understanding how the materials and sediments that make up the seafloor and the fluids within them interact to create the seafloor shape. And he regularly uses innovative environmental observing sensors and platforms to collect geological, geophysical, and oceanographic data for analysis and to advance our understanding of ocean dynamics. Adam's research has taken him to sea on 21 different expeditions, including 8 as our seafloor mapping lead and 1 as a science co-lead on NOAA ship energy.Explore. and also 2 on research vessel Atlantis, working with the ROV Alvin and the AUV Sentry. And he was also one of the first from the NOAA Ocean Exploration team to identify so many cold seeps along the eastern U.S. continental slope. So all of this background makes Adam a really perfect person to field your questions during tonight's question and answer with an expert. So Adam, again, really glad to have you here. Welcome.
Thanks for having me. It's great to be here.
Absolutely. So at this point, we'd like to ask you all to start dropping some questions for Adam in our chat box. And if you're not seeing the chat box, you'll probably need to log into YouTube if you're in YouTube and you don't see it. And while we take a moment for questions to start rolling in, Adam, I've got a couple just to get us started.
Sure.
And we really like to start off with kind of getting to know our expert a little bit more. So when we think about you as a research scientist studying cold seeps at the bottom of the deep, dark, cold ocean, what in the world captivated you that led you to going into that line of work?
Well, Susan, when I was young, I didn't actually grow up near the ocean. I grew up kind of far away from the ocean in the hill country of Central Texas. But here's a picture of me visiting the ocean when I was a kid. And I was immediately drawn to water. And because of that, one of the things I always wanted to do when I was a little kid was be a ship captain. I wanted to like drive oil tankers or cargo ships. You can see in this picture my first command, which was probably also my last command, because I learned pretty quickly that I don't have the vision, or I should say I don't have the eyesight necessary for that exact career path. But I was so drawn to the ocean. And I think a lot of what drew me to sort of that career path was this desire to see new places, to travel, to go out and experience things I hadn't seen before. And that sort of segued into ocean exploration. It sort of segued into a desire to be in the ocean. As you can see here, another shot of me as a child, maybe some very initial ocean exploration there. But I think I took that sort of desire to explore and see new places and thought about, well, where on earth can we go where there's lots of things to be discovered we haven't seen before? And that sort of set me on a path towards an interest in marine science and understanding the ocean, especially the seafloor, that set me sort of towards the direction I would take later in life with my career.
Fantastic. Sounds like we can say you're a curious water baby.
Absolutely.
Nice. Well, if we get into just a little bit of background of what cold seeps are and where we find them, Adam, just to give our audience a little bit more orientation. We recently found hundreds of these seeps off the continental slopes of the eastern U.S. in the Atlantic, and also off the western U.S. in the Pacific. So could you give us a little bit of background about how we recognize them when we're mapping the deep sea?
Sure, that's a great question. So one of the things that the NOAA Office of Ocean Exploration and some of those other vessels we looked at a little bit earlier do is part of their ocean exploration work is mapping the seafloor. And so they have a sonar on the ship that basically creates a sound pulse that travels outwards into the water. And then by measuring when that sound reflects off of things like the seafloor, we can generate a three-dimensional map of the shape of the seafloor. And those type of sonars were specifically designed to create these three-dimensional maps of the seafloor. But one thing they also give us, besides just the shape of the seafloor, is if that sound bounces off of anything above the seafloor or reflects off of anything above the seafloor, we'll see that too. And as you see in this image right here, you have this triangular shaped sort of profile of the ocean underneath the NOAA ship Okeanos Explorer. And so you see that line of sort of lighter yellow and green outlined in a white dashed box. That is a seep being detected with a mapping sonar. So the sound is bouncing off the bubbles, this long stream of bubbles coming out of the seafloor, and that looks to us like this stream coming up from the seafloor. And then we can process those data to create a three-dimensional map like you see here, where each of those sound reflections off the bubbles can be plotted here like you see in this image. And we can trace that cloud of bubble reflections all the way down to the seafloor, and where it meets the seafloor, we know that's a location where this gas, these hydrocarbons, is coming right out of the seafloor. Here's a great video showing showing a ship mapping in real time and creating these maps of these bubble plumes coming out of the seafloor. So really, that process of looking for those reflections and tracing the seafloor is what allows us, as you asked, to be able to find where these cold seeps are on the seafloor, particularly the ones that are generating bubble plumes.
That's amazing, Adam. The technology is phenomenal, and those images that you show us of being able to detect bubbles that are, miles under the ocean,
That's right.
and make those incredibly colorful, incredibly informative pictures is just mind-boggling.
Yeah.
Brittany had asked, and I think this ties into that. She said, how were cold seeps initially discovered? Because I know, we're finding them with multi-beam sonar, which is state-of-the-art technology. But when did we first know there was such a thing, and how?
That's a great question. So the first cold seeps that we know of were discovered in the 1980s off the Florida escarpment, actually in the Gulf of Mexico. And those were discovered with a submersible. So scientists in a submarine were at the sea floor, and they were exploring this very steep underwater cliff known as the Florida escarpment. And one of the things they noted at the base of the Florida escarpment was there were areas where they were seeing actually fresh water or fresher water coming out of the seafloor into the ocean, and realized that this was a location where you had exchange of fluid out of the seafloor, and was one of the first, that was the first discovery of a cold seep. And really a lot of our initial understanding of cold seeps, things like mud volcanoes, those were also discovered with work through submersibles, either manned submersibles or remotely operated vehicles, where you have the opportunity to take a camera image of the seafloor, like we see here at this mud volcano. And this is really neat. You're seeing a mud volcano on the seafloor. This is where gas is coming out of the seafloor, and it is carrying sediment with it, which creates this volcanic shape, this mud at the seafloor. And so this would have been something like a crew of a submersible would have seen in the Gulf of Mexico, or maybe looking at video from a remotely operated vehicle. That's an unmanned submarine at the seafloor, and you would visually see something like that. So those were the first ways we discovered and saw these, was really through serendipity to some degree. We didn't know they were there. We just happened to be there with a submarine and see them. That let us know that these features exist. And then, more recently, we've been able to use some of these mapping tools to really expand our understanding of how many there are.
Gosh, I imagine the first few times people saw those, whether it be in a submersible or from a ship looking with an ROV, had to be a bit scary.
Yeah, I mean, absolutely. So, oftentimes we, especially in earlier years, we didn't think of the seafloor as being as dynamic as it is. We didn't think there'd be places where you had these bubbles of gas coming out of the seafloor. Or even to your point, when we open today, we talk about those hydrothermal vents, and I know, when they first saw those, they had no idea you could have water that hot at the seafloor, and that was a little scary, because they said, "Oh, what could this do to our submersible?" And so, yeah, you're absolutely right. One of the exciting things about exploration is that you might happen upon something you never expected to find there, but I guess that sometimes that can be a little scary too, if you don't quite know what you found or quite know what you're looking at until you get a chance to study it a little bit more.
Yeah. I think we've got several people joining us from the Southeast, and Beth Lindsay has asked us if those cold seeps that are found in the Gulf of Mexico are found off the coast of Alabama, Florida, Mississippi, et cetera. Like, how far away are they?
Sure, that's a great question. So they are absolutely found all across the Gulf of Mexico, and they are most of the cold seeps that we're aware of are a bit offshore. So it's not the sort of thing like you just go right off the beach and necessarily find one. They're in a bit farther offshore in deeper water, but for instance, I had a great opportunity to be one of the science co-leads on an energy.Explore expedition in the Gulf of Mexico in 2018. And we had this fantastic opportunity to travel all the way from Texas across the Gulf to Florida. And all along the way, we found a variety of different types of cold seeps. They were offshore in deeper water, but they're off Texas, Louisiana, Mississippi, Alabama. In fact, right off of Mississippi and Alabama, there's a series of salt domes, Biloxi Dome and a few others, that are very dynamic, very productive gas seeps, lots of gas coming out of the seafloor right there. So we do see them off of every state in the Gulf of Mexico. And as I mentioned, off of Florida was where some of the first cold seeps were discovered.
Amazing. And I know they make their appearance in very different forms. You mentioned the NOAA ship energy.Explorer and when you were a science lead. Can you tell us about a couple of your favorite experiences? I think some of them were in the Gulf of Mexico.
Absolutely. So you make a great point. We see a variety of types of cold seep, and especially on that expedition we did. This image here is a brine lake, and what that is a place where exceptionally salty water seeps out of the seafloor. So there are deposits of rock salt underneath the seafloor, and as they mix with water, they create this brine, which is a very, very salty water, much saltier than the ocean itself. And that brine will flow out of the seafloor, as you see in the image here. That dark area is the brine, and it will flow down slopes, creating even brine waterfalls, which is one of them, what you're seeing here in this image, which is one of the more spectacular things I've seen. That's brine flowing down a slope past those mussel shells and then into a brine pool that sits on the seafloor. And so in the Gulf of Mexico, we see these brine features. We see places where you have natural gas, methane coming out of the seafloor in bubble plumes, like you see in this image here. We also have locations where you see things like the mud volcanoes that we were looking at earlier, where those bubbles of gas are carrying sediment with them up out of the seafloor, creating sort of a volcanic shape. So you can get a lot of different types of seep, really anywhere where you have this fluid coming out of the seafloor or gas, and it's at ambient temperature. That's going to be your cold seep, and as you said, they can have a variety of different appearances. And we got the opportunity to see a wide range of those on that expedition in 2018 that I had the opportunity to be a part of.
Those brine pools are just so otherworldly, that just amazing.
They really are. Yeah, it's really remarkable. And here's a picture of the Hercules actually descending into a brine pool. So you see this is the brine in front of it, and it gets sort of cloudy as the vehicle submerges. And it's almost like a strange optical illusion. You're looking at the bottom of the ocean, and yet it looks like there's a body of water sitting on the seafloor. It looks as if you're walking up to a pond or a lake. But yet you're underwater. And as you can see here, the Hercules disappearing under the surface of that brine pool. And it's really remarkable because you even see things like waves move across the surface of the brine pool and crash against the shore of the brine pool, yet it's all underwater and exists just because of that difference in density between the overlying ocean water and the very, very salty brine beneath.
Yeah, the density difference must be super dramatic.
Absolutely. Yes.
I also wonder about washing that ROV off when it comes back to shore. You got to be really careful with that, don't you?
Yeah, I think I'll leave that to the engineers, but I know they're always washing down the vehicle, get the salt water off, but I think you'd be particularly careful after that because obviously very salty, but also with the seeps, you can have other chemical elements coming out of the seafloor as well. And of course, you probably want to make sure you wash all those off of your delicate equipment.
Yeah. Speaking of those other chemicals, Brittany has also asked us if the gases that are released from seeps are the same as the gases that are released from hydrothermal vents.
That is a good question. So in most cases, in some cases, yes. So in the intro today, we saw hydrogen sulfide. It comes out of cold seeps, and hydrogen sulfide is found at hydrothermal vents as well. However, Most cold seeps, a large portion of, if we see gas bubbles coming out, a large portion of that gas is methane, which we do not commonly see at hydrothermal vents. So at hydrothermal vents, if we see gas coming out of the seafloor, it might be carbon dioxide, but it's not as common that we see gas. It's much more common we see fluid coming out of hydrothermal vents. Whereas at cold seeps, we do see gas a lot, and oftentimes these bubbles are predominantly methane. And that methane can come from a few different sources. The methane at most of the cold seeps we found, for instance, off the the continental margin of the East Coast United States, that methane is produced in the very shallow sediment just beneath the seafloor by microbes, which are consuming organic carbon. So if you imagine all the rivers that bring sediment, they bring eroded sediment down to the ocean and then discharge it into the ocean. That material then falls to the seafloor and piles up. And not only is it sand and silt, but it also has organic material mixed in with it, little pieces of debris, pieces of plants and animals and other things, that organic things that have lived and died. It's mixed in there, and it gets mixed in with the seafloor sediment. And then these microbes that we talked about a little bit, or we saw on the presentation earlier, they will consume that. And through eating it, one of the byproducts of that is methane gas and hydrogen sulfide as well. And so that's oftentimes the source of the gas that comes out of the seafloor. But then in other situations like the Gulf of Mexico, it can come from deeper sources. So if we imagine those really deep basins where organic carbon is under a lot of heat and a lot of pressure, it's turned into oil and natural gas, which are resources we're familiar with that we take out of the seafloor. That natural gas can follow fractures and faults in the rock all the way to the seafloor where it escapes. And that would be a second source for the gases we see coming out at these cold seeps, particularly in the Gulf of Mexico.
That takes me to a spot where I'd like to pull up a mystery question for the audience, if that's all right with you. It just sort of travels nicely with this conversation. I'd love to pull up an image that I'd like to ask the audience to just drop their comments in as far as what you think it is. Oh, well, this is a different one from what I thought, but please, this one works. What do you think this is?
Yeah, we can do this one as well. This works.
Go ahead and drop your thoughts in the chat. We're just going to give you all just a moment to take a look at that and tell us what you think that is.
Yeah, just a few moments to think about what we might be looking at, especially that brown and white stuff in the middle there.
That one might be more telling for folks to identify what they are.
Yeah, that might give them a little bit of more of a clue there as well, looking at it up close.
All right, we don't have a whole lot of answers here. So we've got one that says gas hydrate. There we go, Adriana.
Oh, wow, okay.
Good job. Would you like to explain a little bit about what gas hydrate is in relationship to what you were just telling us about these microbes under the sediment?
That's right. So I mentioned there's two ways we're forming gas under the seafloor, and no matter how you form it, as that gas makes its way upwards through the pore space, the space between sediment grains and the seafloor towards the seafloor, oftentimes it gets trapped in a material called methane hydrate. And then that mystery question, that white, or in this picture as well, that white material we're looking at is methane hydrate. And if you look at it, it looks a lot like ice. And that's because it is very, very similar to ice. So methane hydrate is this white material. And what it is it is frozen water, so essentially ice, but the frozen water is in a crystal lattice. The crystalline structure of the water makes basically a cage, and in the center of the cage is a molecule of gas, usually methane. So this methane hydrate is it's an ice-like substance. It's a special kind of ice that traps gas molecules within it. And so what we're learning is that all along the edges of the continents in the ocean, all around the world, the seafloor has this methane hydrate down within it. So if you looked at our mystery picture, there was sort of that person holding that that white material with the brown on either side of it. That's what methane hydrate in the seafloor looks like. It's within the sediments, in the muds, in the silts and the clays, and it is trapping methane there. And what we now know is that methane in the seafloor along the edges of our continents is the largest reservoir, or the methane hydrate is the largest reservoir of carbon on Earth. So it stores more free carbon than anything else on Earth. So a lot of the carbon in our ocean system is locked up in this hydrate. And the way this plays into cold seeps is that this hydrate, like ice, is susceptible. If you warm it up a little bit, it melts, and then it releases that methane right out of the ice, and it's a free gas that can then move up to the seafloor and be released into the ocean. And so in the ocean, that methane hydrate has a particular range of temperatures and pressures where it's stable and it keeps the gas locked up. And if we start to heat it up, or we start to reduce pressure, which would be something like lowering sea level, that can cause that hydrate to become unstable and release that methane. And when that does, that methane travels to the seafloor and it's released at the cold seeps. Some of the examples we've seen where we see the gas bubbles coming out of the seafloor.
Mm-hmm, mm-hmm. And there's an image I'd love to pull back up on the screen. We call it the methane hydrate amphitheater.
Mm-hmm.
And so here we've got ice underneath a shelf of carbonate rock and mussels. Mussels are hanging off that carbonate shelf, and they're also down below, kind of facing up towards the ice. And my understanding is that ice is exposed from below the sediment because of erosion and currents and such.
Mm-hmm.
But then when that ice is exposed and when these bubbles are popping up, and as you said, this methane is percolating, it's feeding these guys, right? Can you talk to us a little bit about that?
That's right. So if we look at this picture here, what's happened is that white material was methane hydrate that was below the seafloor. And as the bubbles of methane came out of it, the methane was first consumed by microbes. And some of those microbes actually built the carbonate rock shelf that you see on top of the ice. So these organisms took that methane, and the carbon that was within it got put together with calcium drawn from seawater, and they produced this calcium carbonate rock shelf that you see here. And then later what happened is the sediment underneath the shelf got eroded away, and you're seeing that erosion exposing some of the methane hydrate under the shelf right now. So those microbes were actually consuming the methane gas and using it to make rock. But also you saw in those pictures the mussels. These are the Bathymoliotis chilgesii mussels. And what's unique about them, going back to our intro, is that they are sort of at the ground zero for the chemosynthetic community here, because not the mussels themselves, but within them, there's bacteria that is also eating that methane and turning it into carbohydrates. We talked about chemosynthesis as an alternative to photosynthesis, where we use inorganic chemical reactions to produce energy. These microbes live together with the mussels. They have what's known as a symbiotic relationship, where the mussels provide them a place to live and they provide the mussels with food, nutrients. And so those bacteria within the mussels are consuming the methane, producing food, and then that serves as the basis for the food chain for ecosystems around these seeps that can become quite large and complex. So it's not just the mussels, but then you add in other organisms like crabs and fish and shrimp, all that are surviving off of this chemosynthetic foundation of the food chain that comes from bacteria consuming methane.
That's amazing. And our understanding of those food webs is still pretty limited because we aren't able to get down there and see this very often, right?
That is absolutely right. And so one of the things that I've had the opportunity to do is go to sea with some colleagues who are biologists and specifically geneticists. And one of the things that they work really hard to do is sample these organisms. And by doing things like looking at their DNA, understand the trophic relationships. That is basically who consumes who in what order, from the base of the food web all the way up to the apex predators, and what exactly that looks like in an environment like this, and what all of the interactions are between the organisms in terms of either consuming or being consumed. That is something that biologists are just truly starting to figure out about these environments, because as we saw earlier, the idea of chemosynthetic ecosystems itself is relatively new, and then knowing that seeps harbor these ecosystems is an even newer idea. So this is all sort of cutting edge science at this point.
Yeah, yeah. And that image that just popped up on the screen a moment ago, can you tell us what those organisms were?
Let's see. I believe those are those tube worms that I'm seeing there, I think. Yeah. So in addition to the Bathymoleotis mussels, there are also other organisms that have symbiotic relationships with bacteria that serve as the basis of chemosynthetic ecosystems, like tube worms as well. Yeah, there's some more examples of tube worms and mussels together.
Yeah, and look at the biodiversity. There were sea urchins there. I'm sure if we looked closer, there'd be a whole lot of other organisms there. It creates an entire community, right?
That's right. It creates an entire community. And what's important to remember is that in a lot of these places in the deep sea, these are real hotspots of biodiversity. And what I mean by that is you can go just a short distance away from the cold seep, and the image you take of the seafloor might appear, at least initially, to be just barren, flat mud. And that's not the case. There are things living in the seafloor. There's life everywhere in the ocean. But compared to the areas around them, these cold seeps have much higher biodiversity, much higher populations of organisms, and they can even have unique organisms. These are crinoids that are found in the deep sea. We also see corals here, and often sponges that are found at cold seep sites as well.
So, Adam, I know I'm talking to a geophysicist, but another question from Emily. She has asked about the percentage of Earth's life that doesn't require energy from the sun. She imagines that number has changed a lot since we've been making these discoveries.
That is a really, really good question. And I'll preface it by saying I don't think I know, or maybe anyone knows exactly that number at this point in time. As we saw in the intro, prior to the late 1970s, the number, we didn't know about chemosynthesis, so we thought it was 0. And since then, we keep finding more and more chemosynthetic communities. So I don't know the exact number right now, what the count would be. I think for now, we probably would say that photosynthetic communities are much more common. But as was noted by Emily, our awareness of chemosynthetic communities, especially as they relate to cold seeps, we keep finding more and more and more and more. So our understanding of how extensive these are keeps growing. And as noted earlier, they're not just at cold seeps. They're at places like whale falls, and even on land at hot spring communities. So we have, we're recognizing more and more of these communities relative to photosynthetic ones.
And Adam, folks are asking some questions about places that they're familiar with.
Sure.
Carl has popped up a question about hydrogen sulfide bubbles that are coming up in the mud and rocks surrounding the bacterial mats around Palos Verdes Peninsula. And he's wondering if those could be considered seeps.
So I'm afraid I'm not familiar with Palos Verdes Peninsula exactly. Is that in the Caribbean Sea, I think?
I'm not sure.
Okay. Well, maybe Carl can comment in with the exact location. Yes. So if we have hydrogen sulfide bubbles that are being emitted, that would be considered a cold seep. I focus mostly on cold seeps within the looks like it's an intertidal zone.
Mhm.
Okay. So yeah, that's in very shallow water. And although most of the cold seeps we work with are in deeper water locations, there are cold seeps known in shallow water, particularly in Arctic regions. We can have very shallow cold seeps. And for instance, mud volcanoes that we see in the deep sea are also found in some locations on the land surface. We see mud volcanoes as well. So yeah, I think it sounds like if you have hydrogen sulfide bubbles coming out, that these might well be considered a cold seep environment. Yeah.
Palos Verdes
Southern
is
California. Okay, just off
yeah.
LA. Yes, in fact, there are a series of known cold seeps around an area called Coal Point, California, where we have natural gas bubbles coming out of the seafloor. So that area is known to have, and those are relatively shallow. Those are ones that are within 20 or 30 feet of water, or about 10 meters of water, where scuba divers have been able to visit them because they're quite shallow, unlike most of the ones we work with in the deep sea where it's far too deep to scuba dive.
Right. And I know we talk about permafrost, right? And how permafrost can have methane hydrate, or is methane hydrate, I guess. And if sea level rises, that whole dynamic changes and that can melt and be released.
That's right. What we see largely in the Arctic regions right now is that, as you mentioned, we have permafrost, which means the ground is permanently frozen. And in some locations where we have microbial generation of methane, that methane is trapped in hydrate in the ground that is frozen. And with sea level change and overall warming, as that ground that was permanently frozen becomes less permanently frozen and begins to thaw, that will, just like at the cold seeps, that does release the methane out of those out of that ice. In the case of permafrost that's on exposed land, it will release it into the atmosphere, or in shallow water, it will likely move through the water column and up into the atmosphere as well.
Mm-hmm. But we don't worry too much about methane that's percolating from the deep sea as far as its impact in our atmosphere, correct?
That's right. Initially when people hear lots of methanes coming out of the seafloor, a lot more than we might have expected or previously realized, sometimes they say, oh, well, are there implications for the atmosphere or for global greenhouse gas? Because many individuals will recognize that methane is a greenhouse gas. And in fact, in terms of its ability to warm the earth through insulation, it's far more potent than carbon dioxide by many, many, many times. But what we've learned through the work of a lot of other scientists is they've sampled and we now understand that the methane bubbles that are being released at cold seeps, that methane in the ocean actually gets eaten by microbes in the water. So there's these microbes floating around in the water, and as the methane bubbles come up, they dissolve into the ocean. Those microbes are consuming that methane, which means that the methane doesn't make it all the way to the ocean surface and out into the atmosphere. And this is really good news because it means we're not having a very potent greenhouse gas in higher concentrations than thought of entering the atmosphere. So that's good. There are a couple of other effects for the ocean that are caused by this consumption of methane, but it means it's not as much a concern for the atmosphere and global warming. As long as the seeps are generally more than about 100 meters deep, evidence shows that gas isn't making it to the atmosphere.
Gotcha. Blessed be those microbes in so many respects, huh?
That's right.
Just to switch gears a little bit back to those brine pools.
Yeah, absolutely.
Emily had asked a little while ago, she lives in Utah and they have brine shrimp in the Great Salt Lake.
That's right.
And she's wondering if animals can live in the brine pools.
So that is a really great question. We know that those brine pools can have obviously really elevated salinities, and they can have other chemical elements in them that we would think would make them hostile to life. But much like the Great Salt Lake, I think there have been observations of organisms living in the brine pools, and they're a class of organisms, extremophiles, that we're learning can live in very extreme and what we would perceive as very hostile environments and be able to thrive there. So I think there's a lot to learn. To be honest, not a lot of folks have done sampling of brine pools and a lot of research to go in and sample the organisms, see what live there. But I think through our video evidence from exploration, we have seen things like mussels living along the edges of brine pools, which certainly lead us to believe that they're going to be tolerant to that high salinity environment. Here's a great picture here of a brine pool, and we've certainly here you see some mussels along the edge of the brine, and we've seen it in other exploration work where you've seen mussels sort of in areas of brine on the seafloor. So it seems likely that there are going to be organisms, much like the brine shrimp in the Great Salt Lake in Utah, that are going to be able to survive even in these pretty extreme environments.
Incredibly extreme environments. I mean, it's like we said earlier, it's really otherworldly, isn't it?
It really is.
Yeah. And speaking of sort of otherworldly, we have that other mystery question ready now for our participants. So the question to you all is, what do you think this is? This was found a few years ago on the seafloor, quite by accident. And we'll give you guys a few moments just to drop your thoughts in the chat again and let us know what you think it is. Don't be afraid if you're wrong, just drop your initial thoughts in there. Happy to just be quiet for a minute while you all think about that. Nice. One person said a collapsed mud volcano. That's a pretty good guess.
That is a pretty good guess. Yeah.
Some other thoughts? Well, Adam, why don't you start by telling us what you thought it was?
Absolutely. So I remember when this was first discovered, and what all the scientists involved initially thought it was, and explorers involved thought it was a shipwreck. And in fact, it was initial mapping on the maps. It looked like it was a shipwreck on the seafloor. And that's what really spurred the exploration team to send the Deep Discoverer down to check it out. And when the explorers got there, first they even thought it was some sort of shipwreck, but we're really having trouble figuring out, like making heads or tails of what everything was. And pretty quickly they realized that in fact it is a very what we think is pretty unique and rare type of cold seep. And what it is it is a place where asphalt is being extruded from the seafloor. And so a way to think about this is, if you were a kid, or if you have kids and they've ever had that Play-Doh fun factory where they put the Play-Doh in and squeeze it, and the Play-Doh comes out and makes like a spaghetti, it like comes through a port and makes like a spaghetti or something like that. That's what's happening here. But what's happening is under the ocean, some thickened oil, essentially a very thick tar-like substance, is under very high pressure, and it got forced out of the seafloor. And when it came through, kind of like that Play-Doh fun factory, it spread out and it bloomed into this shape we see here. And it was dubbed the tar lily because it looks a bit like a flower. But what it's composed of is tar, which is just very, very thick oil. So this is completely natural. This is oil that was underneath the seafloor that made its way all the way up to the seafloor and then got pushed out and spread out sort of into this flower type shape. And when we were there, what we were seeing was not only do you see the oil, but you're seeing chemosynthetic organisms living on it. And there were, in fact, this was an active cold seep where there were fluids and gases coming out of the seafloor around this feature that were supporting chemosynthetic ecosystem right here on this tar lily. And I think this is the first we've really seen an asphalt extrusion quite like this. It doesn't mean there's not more. That's the fun part of exploration, is just because you found one doesn't mean it's the only one. It just means we haven't looked a lot of places, and we might start finding these everywhere, just like we did with gas bubble cold seeps or mud volcanoes. But for now, I think this is sort of the first we've seen in one of the most unique cold seeps that's out there. And this is located, I should say, out in the Gulf of Mexico, sort of off the coast of Florida.
What a shocking discovery. You think a shipwreck and you find this thing and you're not even sure what it is.
It was a true mystery, even as we started to look at it and explore it, what exactly it was and how it got there.
Yeah. Wow. Well, we've been talking a lot about the Gulf of Mexico, and we just started talking a little bit about shipwrecks. I know you had been privy to a pretty amazing discovery a few years back. Can you share a little bit more about that?
Well, I was fortunate enough to be on the energy.Explore in 2012 in the Gulf of Mexico. And much like that tar lily, we had mapping it indicated there was possibly a shipwreck on the seafloor, but we didn't know very much about it. And I remember this day in particular, one of the challenges was we had really bad weather. So we were all cooped up on the ship. There were high waves. And one of the problems with bad weather is you can't dive. You can't send the submersible down. So we were all sort of disappointed. We weren't going to get to explore this potential shipwreck. And then finally, the weather sort of cleared off in the early afternoon, and everybody worked together to sort of reshuffle the schedule and make it work. And we put the submarine in very late in the day. Usually it goes in first thing in the morning and comes up in the afternoon. We went in after lunch, even in the afternoon, and we're diving. And so by the time we got to the shipwreck, it was late in the evening. And it was one of the most sort of spellbinding things I remember, because everyone on the ship, everybody was huddled around the cameras watching these images come in, because you had this incredibly perfectly preserved shipwreck. Here you see an anchor, you see some bottles, glass bottles that are not broken that were on the ship. There is a couple of cannons from the ship lying on top of each other. And as we started to explore the shipwreck, everything was just so incredibly preserved. You could see the patterns on the china. You could see the navigational instruments with the glass lenses still in them. You could see the compass they used to steer the ship by. And here's a great example. These are it'd be a great mystery item. These are sand glasses that were used to keep time. So these objects were hourglasses with sand in them. And amazingly, they've been on the sea floor now for over 200 years, right? And they're unbroken, and they're laying there still as they were the day the ship sank. So I remember that experience of just being on the ship late at night, everyone huddled around the monitors, just can't wait to see the next thing that comes into the video view, because of just how remarkably well preserved everything is. And the story it's just telling, the history of that vessel and the people who lived on it.
Yeah, the history is amazing, and how well everything was preserved, because you were looking at the anchor at the beginning, and then we were looking at the cannon, and then some bottles and plates. I think we found a sextant on that expedition.
That's right. They found the sextant's a navigational instrument that the seafarers would use to find their position, latitude and longitude on the surface of the earth. And so a sextant it's like a small telescope that you can adjust to measure angles between things like the sun and the horizon. And so it has little lenses in it. And what they found was the sextant lying on the seafloor with this perfect glass lens that had just fallen out right next to it and was sitting on the seafloor. Amazing. You rarely ever see archaeological locations like this so undisturbed, so close to their original state. It's just, obviously I'm not an archaeologist or a historian, but even as a geologist, this is sort of just really spellbinding and entrancing to watch exploration when everyone's just sort of holding their breath to see what's coming next.
Yeah. That ship was early 19th century, is that right?
That's right. It was around 1812 time period, early 1800s, I believe. Yeah.
And so incredibly well preserved.
Absolutely. Yeah.
I mean, I know we all keep using the same term amazing, and I'm seeing amazing pop up on the screen, and I'm just like, it's pretty amazing.
It really is. Yeah.
Switching gears just a bit, and we'll wrap up with the question and answer soon, Adam, but Carl had a great question that kind of takes us to another level. He said there's been an awful lot of talk about hydrothermal vents on the moons of Jupiter and Saturn. Is it possible that there could be cold seeps there as well?
Boy, that is a great question. Man, that's a tough one. So I think it's more likely that there would be hydrothermal vents than cold seeps, and I can quickly sort of explain why. Here on Earth, we think of hydrothermal vents as largely being the result of tectonic processes. And what that means is that the Earth has its own natural heat, and a hydrothermal vent is a place where water is getting superheated by the Earth's heat and coming back out into the ocean. And what makes cold seeps sort of unique is a lot of the gas that we see released at cold seeps is through microbial consumption of organic material. So the microbes are eating organic carbon and breaking it down and making the methane gas that we see. And so the interesting thing is that for there to be cold seeps that have this sort of style of methane production, you would have to have organic material, which means you would had to have had living material on these planets that would have died and collected on the seafloor. I don't think we know yet. I think we're going to have to go and visit with instruments and exploration to find out. But that seems maybe less, in a broad picture, less probable than just having hydrothermal vents, which don't require necessarily any life to drive the seepage that we're seeing there. So it is. I will also say there are cold seeps that do not rely on organic degradation of organic material. So for instance, where we have tectonic plates that are pushing into each other, we can squeeze the sediment and squeeze any fluids or gases out of that sediment. That would be a cold seep that wouldn't necessarily have to have an organic source. And that very well could be found on other planets. And I think we're all very excited to go find out if that's the case. And I know a lot of the work that NOAA's done with exploration is sort of in terms of technological development for how do you explore in the deep ocean is sort of, there's a lot of translation of that technology to things that hopefully we'll be doing in the future with NASA and exploring ocean worlds on other planets.
So much left to discover, so much for the young people of today who will be the us and you of tomorrow, right?
Right. Yeah, absolutely.
Any in closing remarks, any advice for the next generation, given that we've got a whole lot of teachers on the screen tonight?
Yeah, absolutely. So just sort of a few thoughts as we think about the next generation that I would make is that there are lots of ways to get involved in this. And so, as you're working with your students, if they have a passion for something like this, I know you do this, all educators do this already, but encourage them to get involved. A lot of times we see this and we think, oh, ocean exploration, it's marine science, it's all science and engineering. And the important thing to remember is that there are opportunities for everyone, regardless of their skill level. So not only there are scientists and engineers involved in ocean exploration, but there are also people involved in all kinds of other skill sets that they bring to the table, like project management and education, scientific communication, bringing like we're doing here, bringing this information to the masses, videography, storytelling. There's opportunities for anyone who's interested to get involved. And I would pivot on that and also say it's important to let students know that there's room for everyone as well. Unfortunately, for a long period of time, a lot of ocean scientists and explorers have all looked kind of one way in terms of their representation. And it's important to let the next generation know that everyone should be involved and that especially NOAA and ocean exploration is making huge strides to really have equity and inclusion for all groups in opportunities to explore the ocean. So I think that's it's important point to make, that representation is important, and that we want everyone to know that they're welcome, and we want to encourage all the students that are excited and interested by this stuff to jump in and get involved.
Yeah, it's important for us to remember that it's 3/4 of our planet, right? And no matter where you live, understanding the ocean is vital, and being involved in ocean science concepts and understanding them and bringing them into the classroom is really essential. You had an experience in 8th grade. I think that was really important.
Yeah, no, I was going to jump off of what you said there. Which is to say that, maybe as a little bit of a closing story, you go back to those pictures of my childhood and stuff. One thing that I think was a really important turning point was, I remember being in middle school, and we had this overnight trip that we took from where I live to the coast, and over the course of a long weekend or something like that. And we got really lucky. We had the opportunity to go out on a boat with a scientist and do some seafloor sampling. They dredged up some, shrimp and fish, and we looked at them, and just sort of like a focus on marine science. And that really inspired me and made me think, like, or really realize, this is a career and a direction I could go in. But, thinking about it years later, I also realized that was a choice those teachers made, and it's not necessarily that the teachers really wanted to take 35 13-year-olds on a 3-day weekend to the beach. Like, it may not be the best thing, that might not be exactly what you want to do, but they chose to, right? Just like the folks in the Cold Night have chosen to be here, right? And it's important to say that those choices can make a huge difference. And it's really important to recognize the critical and often unheralded work that our middle school and high school teachers do in shaping future generations, and that folks like yourselves have made the choice to come to events like this and bring this information and opportunities to your students. And I commend you for it, and say that I'm better for the fact that Miss Slater, back in let's just say a long time ago, decided to take students on that trip to the coast and give me that opportunity.
Go Miss Slater. Yeah, it's true. If we didn't have wonderful teachers, we wouldn't have amazing scientists. We wouldn't have the amazing, bright people that we have working on ocean exploration across the globe.
Yeah,
so
absolutely.
Adam, cannot thank you enough for being our guest expert tonight. We really appreciate you sharing your experience and your expertise with our group this evening. And again, I know we used amazing too many times, but sorry.
Well, it's been my pleasure. It's a real honor to be here and have an opportunity to talk to these educators. And I thank you for giving me that opportunity.
Absolutely. Well, we look forward to seeing you again soon.
All right. Thanks so much, Susan.
All right. So marine seeps are not only fascinating because of their history and formation processes, but as you all know, they create an incredible foundation for deep sea communities that we are really just starting to understand, as you heard from Adam tonight. And we're really so glad that we have scientists like Adam studying these areas and bringing these important habitats to light. And who knows what your students will do in the future, understanding those habitats even further. So to bring this incredible information into your classroom, we have a list of exceptional SEEP resources and some information on in-person and online professional development opportunities. And with that, I'm going to turn it over to Liz to share some of that information with you.
Thanks, Susan, and thanks again, Adam. It's a really tough act to follow, the two of you. I know I've certainly learned some information tonight. But with that, I'm excited to be able to share our list of resources with our educators joining us tonight. As you've heard from the interview just before this, cold seeps are an exciting topic because they really are so multidisciplinary. There's the chance to bring them into your classroom, whether you teach geology, biology, chemistry, physics, physical science, or even just engineering. And so with that, we've got a diverse suite of resources with you. The first resource I want to bring up on the screen tonight is a resource sheet that you all should have gotten, for those of you joining via YouTube, with your email reminder to join tonight's event. It was linked as one of the resources in that email. If you're joining via Facebook or you got the invite forwarded to you somehow or you missed that email, it is also linked below the event in both Facebook and YouTube in the event details. So this resource sheet is a list that our team curated of some of our favorite resources about cold seeps. We've got lessons and activities. The two highlighted here are the two I really want to speak to. These were just finished last week, hot off the press. They are two student investigations that were developed in collaboration with the National Science Teaching Association about different phenomena available at cold seeps. So we've got a high school lesson here about methane iceworms. For those of you that were really into the mystery items tonight, this is a really cool one to share with your students. These worms are really neat and live in that methane hydrate. And then for our middle school teachers joining us, we have a middle school investigation about fire ice in the deep sea. So again, about methane hydrate. This one's more of a physical science and earth science, whereas that high school lesson there about the iceworms is more of a food webs and life science. Going back to that resource sheet, some of the other available resources that are pulled together here are a group what we call information sheets. So this is really a diverse suite of fact sheets, ocean facts, or just blogs from the field. So some of those firsthand stories from explorers like Adam out on the NOAA ship Okeanos studying cold seeps around the globe. Some of the ones at the top here that are highlighted are, again, some of our newer resources. So we've got our cold seep theme page, which is on the education website or the NOAA Ocean Exploration website. This is where you can find anything and everything that our office has on cold seeps that is ready to bring into the classroom. And then we've got a series of brand new fact sheets that really go into an overview of what are cold seeps and where are they found, cold seep communities, which really focus on the chemosynthetic communities found there. And then lastly, chemosynthesis. And I saw in the comments, we've got some fellow chemosynthesis fans. So really excited to have you check out that one. And then because cold seeps also often come up in contrast to hydrothermal vents, we've got some cool ocean facts linked just below that. And then some more resources on this sheet include our images and videos. So the one I really want to point out is the Deep Sea Dialogues. So Deep Sea Dialogues are a video series that we put together for introductory or to introduce you to a deep sea topic. These include a really short narrated introduction and then an interview with an expert. So just like you previewed tonight at the beginning of the event, we have one on cold seeps that is available, and there's the screenshot of that. We hope you check it out. The full thing is about 10.5 minutes in length, but really a great jump off point to get a broad overview of what are cold seeps. And we've got really great feedback where these videos are also great to bring into the classroom. Students, it's definitely at a level that students can understand. And the last ones I want to share are a series of websites. So first, I want to bring you to NOAA Ocean Exploration. So this is the education page under oceanexplorer.noaa.gov, and that URL is scrolling across the bottom if you've never been here before. So if you visit our education page, you start off with those theme pages. So as I mentioned, Cold Seeps is linked on that resource document. But we have 11 different themes here, and for each one, there's background information or things like those fact sheets, student lessons for middle school or high school students, multimedia from past expeditions pulled together. I saw several comments from the Gulf of Mexico, and I'll show you how to find that content too, as well as some career profiles. Under that, we've got the Deep Ocean Education Project website links, which we'll explore in just a second, as well as some educator opportunities. So additional professional learning opportunities like tonight, and some grants that are for educators as well. As I mentioned, a lot of you and a lot of tonight's conversation was very geography specific and where to find cold seeps. And so one of the exciting things about this topic is they are found in every ocean. So if you're looking for resources about cold seeps to bring to your students and you really want it to be focused on the area you're from, I encourage you to check out our expeditions tab on oceanexplorer.noaa.gov, and you can browse by location. And here you can hone in on different areas. So I can choose Gulf of Mexico. And it does take a little bit of scrolling through and hovering over each to learn a little bit more about it. But all of those expeditions that Adam mentioned tonight, like the Gulf of Mexico 2012 expedition, where they discovered that shipwreck, are linked right here. And then you can dive in deeper to that whole expedition's webpage. And so really go back in time and bring that phenomena to your classroom. And then the last resource to end tonight on, because I know this is a lot and it takes some time to process, but is the Deep Ocean Education Project website. This website is a collaboration actually between our office, or NOAA Ocean Exploration, as well as Ocean Exploration Trust and Schmidt Ocean Institute. The idea behind the site is we recognize that teachers are limited for time, and we want to bring you the best of deep sea resources so that you can bring the deep ocean alive in your classroom without the headache of navigating multiple sites. So we've really pulled all of our best resources that are student ready so that you can dive in, and you can really start right on that first page. This is the landing page when you visit that site. In the search bar right in the top page, if you start typing Cold Seep, if I can spell tonight, you can start to see all of the resources that are available on the site about Cold Seeps right from the home page. If you're coming here more to browse, there's also a Netflix style carousel of content. And so you can scroll through and really see what our featured content is. Our brand new lessons are featured right here on the homepage as well. And then one of my favorite features is the ability to track all three exploration vessels. So NOAA ship energy.Explore, EV Nautilus, and RV Falcor 2. And you can really see who's streaming live. So right now, RV Falcor 2 is actually off the, or out on the Mid-Atlantic Ridge, and they are currently live streaming with their ROV from the bottom of the ocean. To dive a little deeper into the site, we've got just some high-level pages here. The Explore page is where all of that content is held. So again, should look kind of familiar. We've got it organized by themes. And we do have one extra one here on ocean careers, which I know is really popular with our educator audience. And then my favorite feature is the advanced search. So you can filter by topic. Like, for example, tonight we've got Cold Seeps. And then if I was looking for a student activity, I can really start to whittle down that list of available resources to find exactly what I'm looking for to bring this topic into the classroom, regardless of what the organization is that made it. If you're looking for additional opportunities to engage with ocean exploration, the vessels page is a fun one. So we've got a map that shows you where everybody is in the ocean. You can see energy.Explore ship track here. We're just off the coast of the US and ready to launch our expedition season as well. Again, you can see who's live streaming and go straight to their feed with one click. And then I think a really powerful tool for educators is the calendar at the bottom of this page. So you can really see what's up and coming and start to map out when you want to show the live stream in your classroom instead of it being in the moment. The events and opportunities page is another great option. Coming up, we've got some professional development events that go beyond the scope of tonight's and really dive deeper into the resources themselves. So how to bring this topic into the classroom with an emphasis on teaching and instruction. So definitely check that out, and we'd love to see you register for one of our events. We have both virtual and in-person opportunities coming up through our Alliance Partner Network, which are museums and aquariums and universities all over the country. So check that out and register with one of those today. And then down below, we've got some programs and opportunities as well that are both for teachers and for students. So there's some internship or fellowship opportunities here, as well as grants and other programs or ways to connect with the ship. And then lastly is the accounts feature. So I know when I was a classroom teacher, my biggest frustration wasn't just going to Google and searching for a lesson and being overwhelmed by the millions of responses that came back. But worse was when I finally found a really great resource, but then I couldn't find it later and I couldn't come back to it. So one of the powerful features of this site is the ability to create a free account. And once you do, you have the ability to create collections or your own folder system to save any of the resources that are available on the website, however you want to label them. So I've already created a Cold Seep resources collection for tonight. And as you can see, I've put the deep sea dialogues in there, our student investigations, fact sheets, as well as additional resources available from our partner organizations. And it doesn't end there. Not only can I make great collections for myself, but I can share them, and I plan to with all of you tomorrow So with all the emails that you use to register for tonight's event, I'll type them in tomorrow and you'll receive the same collection to start building and exploring the site yourself or share with a colleague. If you did not register for tonight's event and you joined us live through Facebook, our email should come up and be scrolling across the bottom now. Please feel free to send us an email with your email address, or we would get it then. But that way we can save it and make sure that you get all of this great content as well. So again, our email is oceanxeducation. Let's see if we can get that banner coming up. There we go, at noaa.gov. And it's also all over our education website as well. And with that, if I haven't overwhelmed you already, I think that's the bulk of tonight's resources. To wrap up our night, kind of summarizing the event or the interview with Adam, as well as all the resources we shared, we really want to hear from you what you thought of tonight's event. And so with that, we would love for you to participate in our word cloud. So this once again uses Menti. So you can either scan the QR code that's on the screen, or you can type in the list and the code there, or under the resources for this event, you can also use a direct link to go as well. But please share a word or two about how or what you think about tonight's event. What were the highlights? What was your favorite part? We love to hear it all. And as that populates, I'll head back to our professional development opportunities. And again, if you missed that QR code, you can go straight to the Menti using, it is under the video in the resources section. But as you guys are typing in some words, again, wanted to share those upcoming events. So our professional development workshops are up and coming, again, around the country at our alliance partners, and a chance to really dive deeper into those classroom resources. So we'll be modeling those 2 student investigations. If you're participating in person, you'll also get materials to do them in your classroom. And virtually, it depends on our alliance partner, but would love for you to join us. So if you're going to the education page on NOAA Ocean Exploration, you can find that under Education. Professional Development will take you right here under Educator Opportunities. At the top are our deep dive events, which is tonight's event. But further down, the professional development workshops and view all available opportunities will take you to where you can register at the site nearest you, or join us virtually at a site from afar and meet some new colleagues. And with that, hopefully we've had some responses in our word cloud. See if we can get that pulled up as well. Oh, I see it growing. This is great. What are those top words coming in? Got to make my screen a little bigger. Amazing. We did say that a lot. Cold seeps are fantastic. Fascinating. Groundbreaking is great. Increased my curiosity. I completely agree. Our team really dove in to this topic in order to prepare the materials that we shared with you tonight, and really, really enjoyed going into so many different directions about the biology, the geology, especially chemosynthesis, and love to see that it's piquing your interest too. Bubbles are great. I don't know about you, I find the videos of the bubbles trickling up very, very peaceful. Methane hydrate, that's great. Brine pool's awesome. The brine waterfall footage that we shared is some of my favorite, really incredible. And I have to say, if you watch that video, it is linked in that resource document. There's some really great audio from the explorers. There's nothing more infectious than when scientists are like kids in front of a screen, seeing something for the first time. And you can just feel that excitement of finding something. And with that, I will turn it back over to Susan to bring us home for the evening.
Thanks so much, Liz. Love seeing the word cloud and love seeing all of the fantastic resources that are available on Cold Seeps from a number of different exploration organizations. We really hope that you'll take the time to take a look at those and incorporate them into your teaching. As I think many of you may know, you can use the ocean to teach a number of different science concepts, and we hope you'll consider cold seeps and chemosynthesis as a key element of all of that. Again, thank you, big thank you to Adam for his time and sharing his expertise with us. And if there's any burning questions that we didn't get a chance to answer, I think there were certainly a few there. Please feel free to send them to us using the email address that Liz mentioned earlier, oceanexeducation@noaa.gov. Or if you're attending one of our Cold Seep professional development opportunities, bring your questions along with you, and there'll be some folks who can probably answer them there. We'd also like to thank our team and crew behind the scenes from NOAA Ocean Exploration and the National Marine Sanctuary Foundation and the University of Rhode Island's Inner Space Center. It's been really wonderful to see all of the enthusiasm here tonight, and we really would like to thank all of you for participating today. Until next time, we hope that you have a fantastic evening. Thank you so much.